Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the concept of galvanic cells. What is a galvanic cell? Well, galvanic cell consists of a circuit basically that's comprised of two half cells, one connected to a switch and the other one to a voltmeter. And one half cell has a metal in it that's going to be undergoing reduction. In this case, that metal is silver, and the other metal is going to be undergoing oxidation. So, in this case, copper. Whenever we're looking at a galvanic cell, there will always be a salt bridge. And that salt bridge, along with these electrolytic solutions, are designed to keep your solutions neutral. So, what is a salt bridge? A salt bridge contains ions. It's a porous material, allow ions to pass through, but nothing else. So, basically what will happen is either in this scenario, we're going to have silver undergoing reduction. This side is going to be copper undergoing oxidation. So basically in a galvanic cell, there's going to be a spontaneous movement of electrons here due to the fact that there's a difference in reduction potentials for both of these metals. So one of these metals is easier to oxidize than the other. In this case, it'll be copper. And if you were to look on activity series, copper would be above the silver on the activity series. And basically what happens here is when you flip the switch, there is oxidation that occurs here, and the copper literally comes off the solid as a cation, leaving the electron behind, which then gets transferred through the voltmeter to the other side. So this is undergoing oxidation. It's giving up electrons. So therefore, this copper solid is the reducing agent. It gives up the electrons so that reduction can take place. Then on this side, we have silver. The bar, the cathode, is picking up all this excess negative charge. All these electrons are being deposited over there. So what happens is we end up pulling some of the silver out of the solution. This solution is silver nitrate, for instance, and the positive cations get drawn to the excess electrons that are found here on the cathode. So silver comes out of the solution, starts accumulating on the cathode bar, whereas the copper electrode, the anode, is undergoing oxidation and losing mass into the solution. So when this occurs, we have charge buildup occurring, whether it's the 2+ charge for every copper atom that we oxidize, or whether it's the nitrate left behind here, right? Remember the silver had a nitrate attached to it right there? So let's go ahead and write that in. So there's a nitrate left behind when that silver goes and sticks to the cathode. The salt bridge, what it can do is either pull that nitrate back in or dump in a cation to neutralize that newly formed nitrate anion. Whereas on this side, we can have the copper leave the solution and go into the salt bridge, or an anion come out and neutralize that 2+ charge that was just created. Okay? The electrons always travel from anode to cathode. It's an alphabetical order. All right? These are the basics of a galvanic cell. This is the shorthand notation. It's always going to be the anode solid. Then the electrolyte, we only care about the cation. So in this solution I had copper sulfate, and in this solution it was silver nitrate. So of both of those, I only care about the silver and the copper. These do not have to be the same thing as the metals here. Okay? This is for a galvanic cell. So I hope I've given you enough information for you to understand the basics of a galvanic cell. Make sure you check out the other videos pertaining to electrochemistry. Thank you and have a nice day.